Let's discuss sums based on the trigonometric identity that we learned. We are going to discuss these two questions. Let's start. Express the ratios cos A, tan A, sec A in terms of sin A. So we need to get these following ratios, three ratios in terms of sin A. There should be only sin A. If I write tan is equal to something, if I write cos A is equal to something, there should be only sin A. If I write something like sec A is equal to whatever, it should only consist of sin A. Let's start. It's very simple, don't get confused. Let's start with the cos. So we have the identity. For that we need to have identity of cos and sine. We know that, which is sine square A plus cos square A is equal to 1. Now I want in terms of sin A, and cos A should be subject. So let's shift sin A over there. That will be cos square A is equal to 1 minus sine square A. But we want only cos A. I told you in previous session you can take square root as well. So let's take square root. So square root of cos square A is equal to square root of 1 minus sine square A. Simple. Here square root will be cos A, only positive, then square root of 1 minus sine square A. That's the first answer. This is my first answer. Cos A is written in terms of sine A. Done? Now let's do sec A first. The reason behind that, cos A and sec A, they are reciprocal of each other. So let's do it. Here we have sec A. We have sec A is equal to 1 over cos A. So what I need to do, I only need to substitute value of cos A over here and I'm done. So here 1 over square root of, what was the value? 1 minus sine square A. Done? So my second answer is also done, right? So I can write here sec A. Done? Now what's left? Which is tan A. So let's discuss for tan A. How tan A we can do it? Do we know the value of tan A in terms of sine and cos? Yes, we know that. So we can write tan A is equal to sine A over cos A. Now numerator is already sorted out. It is in terms of sine only, but we only need to replace the cos. Now cos value we have calculated at the start of the sum, which is square root of 1 minus sine square A. So I can write here sine A is equal to sine A over square root of 1 minus sine square A. Done. This is the value of tan A. So my answer is done. Let's repeat. Cos A, tan A and sec A, we need to write in the form of sin A. So we have this first identity, sine square A plus cos square A is equal to 1. Make cos A as a subject. Here we have cos square A, so take square root. So we get the value of cos A. One ratio is done. Now sec A. Sec A is what? 1 over cos A. Substitute the value and we are done for the second ratio as well. So for tan A is equal to sin A over cos A. Numerator is already sorted out. We need to substitute the value of cos A. We already have it. So substitute the value and we are done there. Let's discuss the next sum. Here we need to prove something. This kind of questions are going to come in exam as well, that you need to prove one LHS is given and RHS is also given, and you need to prove that if you solve LHS you are getting RHS, or vice versa also you can do it. Right? Let's do it, but it depends on the question that we are going to do in a different way. We'll discuss those questions as well. No worries. Let's start with this one. Prove that cot theta plus tan theta is equal to sec theta and cosec theta. You must be thinking, how can we just add and we can get the answer this one, right? Don't get confused. We need to use many concepts we learn in this chapter, means all the concepts that we learned so far. You can take reciprocal ratio as well, right? Then you can take this kind of relation, tan A is equal to sin A over cos A as well, right? And we need to simplify as well. So let's start, or identity as well. Let's start. cot theta plus tan theta. So I am starting with the LHS. LHS is cot theta plus tan theta. Now whenever you have question in the form of cot theta, tan theta, sec theta and cosec theta, try to convert in the form of sine and cos. Try to convert into sine and form, because we know from cot theta and tan theta we cannot get directly sec theta and cosec theta. We know there is a relation, but let's avoid it. We can even do that as well. So what I'm going to do, first I'm going to convert in terms of sine and cos, right? So let's do cot theta is equal to cos theta over sine theta, and in this case it is sine theta over cos theta. So you must be thinking now it is in the form of fractions, right? How can we add it? You know, well, when we deal with the fractions, we always take LCM of the denominators. So here LCM of sine theta and cos theta, you must be thinking how to do it. Remember, when you have sum like 1 upon 2 plus 1 upon 3, then what do? You multiply 2 3s are 6 is the LCM, right? In the same manner we need to do sine theta and cos theta. Those are two different ratios. So I'm going to take multiplication of their product as the LCM. So here I will be multiplying with cos theta here, and here I will be multiplying with sine theta to the numerator. So let's multiply. So that will become cos square theta plus sine theta multiply with sine theta. That will be sine square theta. And in denominator, product of two denominators as LCM. So here sine theta into cos theta. Done? Now here cos square theta plus sine square theta. You must be thinking that we can use identity. Yes, we need to use the identity. It is given sine square A plus cos square A is equal to 1. As far as your angle is same, theta here. So I can replace numerator with 1. So 1 here, and denominator what's left? Sine theta into cos theta. Now we want answer as sec theta and cosec theta. Now we have a relation between sine theta and cos theta to convert it like that. So 1 upon sine theta is what? Cosec theta, and 1 upon cos is what? Sec theta. So let's rearrange it. Sec theta multiply by cosec theta. Done? That is my RHS. So my proof is done. Now let's repeat the step one time. LHS is equal to cot theta plus tan theta. Whenever cot and tan is given, try to convert in the form of sine and cos. So I did it. Then I have taken the LCM. Be careful while you take the LCM of these trigonometric identities. It may be confusing in the start, but you will be habitual. Practice. That's important. So cos theta into cos theta, cos square theta, sine square theta. This is the identity numerator. So replace with 1. Denominator sine theta and cos theta. So 1 upon sine theta is what? Cosec theta. 1 upon cos theta is what? Sec theta. So arrange it, and you can say we have proved LHS is equal to RHS. Let's discuss 3 more questions. Prove that 1 plus tan square theta over 1 plus cot square theta is equal to tan square theta. So here also same as the previous question we discussed. We need to prove LHS and RHS equal. Let's start. So let's write with LHS is equal to 1 plus tan square theta and 1 plus cot square theta. Okay, so whenever square is there, try to use the identity. It will be very helpful. Now we know that 1 plus tan square theta is equal to what? Sec square theta. Simple identity. And we know 1 plus cot square theta is equal to what? Cosec square theta. Done. So we are going to substitute this. Let's do it. So here sec square theta in numerator and cosec square theta in denominator. Done. Now what to do? We want to get tan square theta only. So let's convert this sec and cosec into sine and cos. So let's write separately sec square theta multiply by 1 over cosec square theta, right? So if I want to write sec square theta in terms of cos square theta, what will it be? 1 by cos, and it is square, so square theta, and here 1 by sine square theta will be there. Done? Simple. Remember, now this sine square theta will go into numerator. So numerator, what will it be? Only sine square theta, and denominator now only cos square theta. Now sine theta by cos theta, we know very well it is tan square theta, and that is my RHS. Simple. Let's recall one more time. It's given very simple. We need to use only two concepts, one for identity, another for reciprocal ratio. Let's start. 1 plus tan square theta, answer is sec square theta. 1 plus cot square theta, answer is cosec square theta. Now we have simplification in form of sec and cosec. We want to convert into sine and cos. Sec square is 1 upon cos, cosec is 1 upon sine, but it is squared, so don't forget to put square. This sine square theta will go into numerator, so numerator and denominator. So if we want to write in one term, that is tan square theta. Done? Let's move to the next question, which is prove that sine square theta plus 1 over 1 plus tan square theta is equal to 1. Okay, so let's start with the LHS only. LHS is equal to sine square theta plus 1 over 1 plus tan square theta. Done? Now 1 plus tan square theta we just discussed, which is sec square theta. So sine square theta plus 1 upon sec square theta. Done? Now 1 upon sec square theta will be what? Cos square theta. So here sine square theta plus this will become cos square theta. Now sine square theta and cos square theta, angle is also same, square is there, plus is there, so what's the answer? Identity only, that is 1. Simple. Let's recall one more time. It's given sine square theta plus 1 by 1 plus tan square theta. We know 1 plus tan square theta is what? Sec square theta. So 1 upon sec square theta. Now sec square theta, I'm going to use reciprocal ratio. So it will become cos square theta. It will go into numerator. So if we use the identity, that is sine square theta plus cos square theta, it will be 1. Simple.